The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Making Triple Digit Adjustments in the Decimal Portions. In the previous problem, we dealt with a situation where we had double digit adjustment in the final result, as the total added value in the conversion process was a double digit number. Let us slightly alter the example and demonstrate the process of making triple digit adjustments in the final result. Let us see how this can be done using the example 42.35249 plus 26.4218. The adjustment technique involves converting the last two digits of the decimal portion into its higher digit value. Here, 352 are the first three digits of the decimal portion and 49 are the last two digits. We can convert 49 into multiples of 100 and add it with the digit 2 of the decimal portion. That is, the 2 can be increased by 1, thus making the 4-digit number as 353. The meaning is that we have added 51 to 49 to make it as 100, which means the one with existing 352 makes the number 353 with the last two digits as zeros. Likewise, let us take the second decimal number, in which case the decimal portion is 42318. Let us convert this into three digits. That means it becomes 424, indicating that we have added 82 to the last two digits 18, thus making the last two digits as zeros. Technically speaking, the fourth and fifth digits of the numbers become 0. The meaning here is that we have added 51 to the first number and 82 to the second number, and therefore the total 133 should be subtracted from the final result by treating the decimal portion having 5 digits with the last two digits as zeros. With this process, we have converted the two numbers as 42.353 and 26.424. Let us consider this as whole numbers and set it from the right extreme of the abacus. That is 4 in the units column, 2 in the tens column, 4 in the hundreds column, 6 in the thousands column, and 2 in the 10,000s column. Let us set the second number at the extreme left of the abacus for reference. That is 4 in the extreme left, followed by 2, then 3, followed by 5, and finally 3. Let us add 4 with 2, that becomes 6. Let us add 2 with 6 in the thousands column, and this becomes 8. Let us add 3 with 4 in the hundreds column, that makes it 7. That is, add 5 in the upper abacus and clear 2 in the lower abacus. Let us add 5 in the tens column, and finally we have to add 3 in the units column. That is, add 5 in the upper abacus and subtract 2 in the lower abacus. we get the result as 68777. We can notice that the dot on the separating bar is distinguishing the whole number and the decimal part. If you reconvert the result into a decimal number, the result we get is 68.777. As we have converted the 5-digit decimal part into 3 digits by making the last 2 digits as 0, we have to take the number as 68.77700 for making the final adjustment. We already mentioned that in making adjustment, we added 51 to the first decimal number and 82 to the second decimal number. That means we have added 133 in the conversion process. That should be subtracted from the decimal portion of the result, which makes the number as 68.77567, as subtracting 133 from 700 gives 567 as the last 3 digits. In case the child needs assistance in subtracting 133 from 700, that can be treated as a separate problem using the abacus, and then the result can be noted. The recent examples clearly demonstrated how conversion of decimal portions to a maximum of 3 digits will help the child to adapt normal addition procedures. In recent examples, we use the same number of digits in the decimal portions, and therefore the process was less complicated. Let us see finer adjustments that should be made in case the number of digits of the decimal portions of the numbers are different.